think we can start. So welcome everybody to another UCAR Africa Initiative Seminar. For those who don't know me, my name is Ana del Moral Mendez, and I am part of the UCAR Africa Initiative, working here at the National Science Foundation National Center for Atmospheric Research, or NSF-NCAR, and I'm part of the Earth Observatory Lab. I'm a project scientist here at NSF-NCAR. So I'll be hosting this session today here, and also joining me is Dr. Kelly Nunez, also working here at NSF-NCAR at MCube Lab. And today our speaker is Daile Zhang, and is an assistant research scientist at the Earth System Science Interdisciplinary Center at the University of Maryland. Currently, she's working on evaluating and assessing lining data from different lining location systems, including ground-based and satellite-based networks. Daile serves on the board of directors for the African Center for Lining and Electromagnetics Network, or ACLINET, and is a member of the U.S. National Lighting Safety Council. She also serves on the World Meteorological Organization's Committee on Weather and Climate Extremes, and helped certify 2 new mega flash lining records in 2022. So Daile, thank you so much for being our speaker today in this seminar series. Just as a reminder, you now have 45 minutes approximately to present your work, to allow for some questions at the end. And for those of you in the audience joining us today online, please submit your questions for Daile through Slido, and we will read those questions and discuss them during the Q&A session at the end. So Daile, welcome, and the virtual floor is all yours.
Thank you, Anna. Let me share my screen. Can you see my, oops, can you see my screen?
Yeah, okay. All correct.
Good morning, good afternoon, good evening, everybody, depending on whether you are. So I'm going to talk about what we have been doing for lightning and lightning safety in Africa. So this is not a very technical presentation per se, but rather more of like what the challenges we faced and what achievements we have been made. So all of the work that I'm going to present today is actually a group effort, and you can see there's so many names on the slide, and I won't have time to read all their names, but I do want to take the time to thank all of them for their support, for their time in doing this work. So we'll start with something more familiar in the United States. So this is the average number of US lightning fatalities in the most recent 20-30 years. As you can see, we have on average 20-30 people killed by lightning annually during the most recent 5-6 years. Compared to 20 years ago, we have about 50 to 60 people killed annually. So we're seeing a promising decreasing trend in the lightning fatalities in the US. And this is due to better education, better warning system, and better medical system. We have, cell phones, so the National Weather Service can send out the warnings, and then they do send out the warnings on the radios as well. So these are helpful for people to find a shelter when there's a thunderstorm. So the death rate per million population in the US is pretty low. That's like the most other developed countries. So this is death rate per million people by state, and as you in the first column here. So you can see that mostly it's less than 0.2, although we have one exception in DC, and that's because of the 2022 event, which was one single strike knocking down 3 people, actually just right outside the White House when they were hiding under a tree for the rain. So that was the only exception in DC. So in the US, we've always been promoting the slogan, "When thunder roars, go indoors." And this has been in the lightning safety community for a couple years already. Basically, lightning injuries and fatalities happened when there was no rain or little rain, because people tend to find a shelter when it was raining. But lightning do happen before and after the rain, and people usually comes out after there's no rain or little rain, but there still was electricity in the atmosphere, and so lightning could also happen right after the rain. So most of the fatalities in the US were related to entertaining activities, including golf, hiking, fishing, swimming. So these are the events that we can prevent. So better education will be needed, so we can work together to continuously decreasing the numbers and hopefully to get that number down to 0 in the future. However, the story is not the same in Africa. Why not? So these are the residence houses and buildings in some African countries. And a good estimate is that 90% of the sub-Sahara dwellings are not lightning safe. As you can see, those buildings are made by hut, stones or mud, so they don't have the metal wires that can divert the lightning current, so they're not lightning safe. So a good majority of the, a good portion of the lightning fatalities and injuries in African countries are actually happen when people were at home or inside their home or buildings, which is different from the US or some other developed countries. So things are complicated in Africa. So when we say, when thunder roars, go indoors in the US, is it gonna be, is it gonna work in Africa? It's a question mark. What works in the US does not always work for other countries. So we really need people who understand what's going on in Africa to help us to work around these situations. So I've been working with a nonprofit organization called the African Centers for Lightning and Electromagnetics Network, or ECLONET for short, for many years. The mission of the organization is to reduce death, injuries, and property damage from lightning across Africa. Lightning causes death and injuries across Africa. Lightning also kills livestock. It's still a measure of family wealth in many African countries, and lightning causes direct damage to utility infrastructure, communication system, and especially damaging remote areas where they already have a challenging economy. So how ECLONET started? So back in 2011, on June 28th, one single lightning strike struck the Ranyaya primary school in Uganda, killing 18 children and injured another 38 children. I'm giving you a heads up. I'm going to show you a very disturbing photo, but it's what happened in the real world. So this is what happened. And what the parents saw when they came to claim their dead children after the lightning strike. And another 70 other killed by lightning in the next few months. After that, 2 of the people, and actually 2 of the co-founders of ECLONET, Richard and Marianne, met in Nepal. They were participating in one of the conferences in Nepal, and they were sitting together. They had a conversation. Richard was originally from Uganda, so he knows what was happening. So they had a conversation of this lightning event. What Richard was saying to Mary Ann is that we really need people to help us, help our country, help our kids, help our people. But whenever I talk to people, they're like showing some sadness, but then they're gone forever. Mary Ann didn't want to be one of those person. So they took the lead and formed the ACLINET. So in 2013, they established the African Center for Lightning Information and Research. And the next year, they hosted a symposium across Africa to help people from other African countries to prepare for lightning disaster. So we start with Uganda because one of the co-founders, Richard, is originally from Uganda. If you don't know too much about Uganda, this is the geography and the lightning density. So there's in the southeast of Uganda, there's a Lake Victoria, and this is where we measure the most lightning strikes in Uganda. We have 2 million lightning strikes detected in Uganda every year. We cannot change the general infrastructure in Africa, so we need to have some priorities. So we decided we want to protect schools first as the most substantial buildings. And why schools? Well, these are some of the cases where we have very many casualties. So you can see mostly they were in school because you have a lot of people in the same area in schools. So schools are vulnerable. Students are the most commonly reported injuries. And because of that, a lot of parents are afraid to send their children to schools because children can, be killed by lightning in schools. And most of the Uganda schools do not have lightning protection systems that can protect the children and the teachers. They're either having some technology, but they're old and untested, so they don't work, or they don't meet with any standards. Because for lightning protection systems to work, you have to meet certain international standards, and I'm going to talk about that later. And one of the common claims is that one lightning system or arrestor or like a one lightning rod will protect an entire building, an entire school, or even an entire village a couple of kilometers around the school. And that's so wrong. So better education is needed. This is an example of 8 students killed by lightning. Because they didn't have the lightning protection system. This is another example. It was on the news. The head teacher was saying the school has a lightning conductor, but it didn't work. It looks like this. We have one conductor erected on the building. We cannot think of lightning striking us. So to have a lightning protection system to work, you need the grounding, you need the metal wires to connect the lightning rod or lightning system, and then divert the current to the ground. So only single conductor here is not going to work. So the ACLINET protects school using the International Lightning Protection Standards. If you don't know that, it's the IEC 62305. So this standard tells you what kind of system you can use to help protecting lightning, protecting schools from lightning. So we formed a lightning protection working group. So we have scientists and engineers, and we also train the local engineers. And so the lightning protection working group will go to these schools to install the lightning protection system and maintain the system when needed. So these projects were funded by the donors and a few family foundation grants. So here's an example of a primary school that we have protected. So we have these scientists and engineers go to the site and install the lightning systems, the wiring, the grounding system, and the lightning rods, and the down conductors here. There's another school that we protected, and you can see that the conditions are very bad. And here they don't have electricity, they don't have internet, they don't even have the clean water. So helping them really was difficult, and it needs a lot of effort and work to ship the materials. And you can see the road conditions are really bad. It's very muddy and dusty. So having these systems to ship there in a rural area in Uganda is not easy. And, you know, installing these systems requires time and work. So Equina has been for 10, 11 years. So what have we achieved? So here are some of the major achievements that we have made. So first of all, and the biggest achievement for us is we have installed lightning protection systems in 7 schools in Uganda, which protecting 11,000 students and teachers and their families. And we have been doing lightning safety education seminars for students, parents, teachers, and local officials. And we have collected the largest publicly available lightning casualty database. Out of 55 African countries, we have collected this database for 41 countries. We have been doing research on lightning disaster and the medical effects by lightning. We publish papers and we go to the conferences. We have the monthly newsletters in 5 languages: English, Spanish, French, Portuguese, and Arabic. And I'm going to go into a little bit details on each of these. So here are the 7 schools that we have protected, and these are the timeline from the oldest and the newest. So here is the map of these schools, and you can see that they're across the entire country. And currently we have 7 schools that have been installing the lightning protection systems. And we are going to install the 8th school, which is in here on the island of the Lake Victoria here. So we are also planning to ship materials and get funding for installing the 9th school and the 10th school. We also do lightning education. So this is an educational lightning booklet that me and Ron wrote back in 2017. It was published by Isabella, and it was translated into Spanish and Chinese, and it was put in online and free to download. And most recently, a volunteer has translated this booklet into 2 African local language, Luganda and Kiswahili. So we're gonna have it distributed into these areas. In addition to these educational booklets, we also host seminars for students, parents, teachers, and officials and community leaders to help them understand the physics of lightning and the lightning safety principles. We also do public service announcements on radio and TV. We also do newspapers inserts, because still there are people using newspaper as their main media resources. And we also do proposals to Ministry of Education and Sports in Uganda. And we have we've been making progress, and I'll cover that in a little bit. I'm going to skip number 3, which is the largest database that we collected, and I'll get to that in a little bit. but we do research in publications. So we publish, we go to meetings. So these are the people that have been helping with ECLINET for many, many years. A little bit out of topic. This guy, Zhang, is from Malaysia. Malaysia is the only country that requires lightning protection system on their building, and it's written in the law. So it's really an effort to protect people from lightning disaster. So we publish papers, conference proceedings, and we publish books. And these are archived on the website, and it's free to download. We also send monthly newsletters. As I said earlier, it's available in 5 languages. We have volunteers translating these newsletters for us. And these newsletters were sent out to a couple hundred readers in Africa, Europe, Asia, and Americas. And the newsletters are archived since 2018, so it's been many years. So what are the challenges we have been facing? Well, nobody cares. Yeah, so nobody really cares. So currently I live in Maryland. So if I'm telling people around me saying, hey, I'm helping a K-12 school in Maryland, then people would say, oh yeah, wow, that's good. But if I'm saying, okay, I'm actually helping a primary school in Uganda, what people will say, well, oh yeah, well, okay. So people really don't care about, the places and the people where they don't know. Think about yourself. Can you name a city or a place in Uganda? Do you know what is the capital city of Uganda? Or do you even know what languages Uganda use, right? So people just don't care about a remote country or the people in that country. And because of that, we have very limited funding opportunities and donations. Funding agencies usually don't care about Africa. And even if it's a funding agencies aimed for Africa, they look for projects that have larger impacts. So if you're telling them we're only going to protect 200 people, and that's not going to something that they want to fund. So we are facing a lot of challenges of finding funding to protect more schools. And because of the limited funding and donations, we are losing a lot of people who were or having been working on this project. We used to have people in other countries who are doing some work, but because we don't have fundings to fund all these countries, so we're actually losing some people from other countries. We have to face bureaucracy at different levels, layers of bureaucracies. We need to pay fees. We need to pay taxes. Even though we are helping their children, their next generation, their people, we need to pay to do that. There's always trust issue from the locals. You're different, you look different, you speak different languages, you come to, install stuff on the schools. So you have to have better communications, education with them to gain their trust, to make sure they're not going to disturb the installation. There's also the lightning myths and traditional beliefs in Africa. For example, in Africa, they're always going to say that if you're wearing red, like I'm wearing now, you're going to attract lightning. Or you cannot look at a mirror during a thunderstorm, something like that. And also, some countries, they believe that if somebody's got killed and injured by lightning, that's kind of a sin from the god. So they tend not to report or think it as something they want to hide, so we don't get these reports. Maintenance. Even we can install the lightning protection system, we cannot just leave it there and not maintain it. Even having a car, you have to maintain it, right? So for a lightning system to work for years, you have to make a regular maintenance. So as you remember, the schools are across the country, so we really need to drive a lot of miles to go to these countries, and the road conditions are bad. We need to do regular checkups. But luckily we have, the parents and the teachers in the schools who will do the checkup for us. And if they see any issues, they'll report to us. It's not only the erosion of the wires, but also because the wires are made of copper. So sometimes the local people will steal those coppers. So we're facing a lot of things that's unusual. There's also the cultural differences and language barrier, but compared to the other things, it's not a big issue. But we have exciting news. So finally, the Aquilina team meet with the First Lady of Uganda. It was on the news here. So it took a lot of effort to schedule a meeting with her and finally met her. We actually had a meeting scheduled to meet with her last year, but unfortunately she had a meeting with someone else, a very big politician. I'm not going to say their names. So they canceled the meeting, but luckily we were able to schedule another meeting a couple months ago with her. So we met her, and as a result, she signed a temporary tax waiver for our imports of the installation materials. So because of that, our first shipment of the materials for the 8th school is already here in Uganda 2 days ago, a couple of days ago, sorry. And it saved us approximately $2,000. And we are expecting more materials to repair the first 6 schools we have installed to come next week. So it's going to be more money to save around $5,000. So after 10 years of effort, we finally got this, a temporary tax waiver to save us some thousands of dollars of money for the shipping materials. And more exciting because of the installation, I'm going to Uganda next week. Actually, right after this meeting, I'm going to run to the health center to get the yellow fever vaccine so I can go to Uganda next week. But I'll help with the team for the installation and then continue the education program and lightning safety at the school and the district. And we'll meet with the district and local officials and meet with the team. So the 8th school, Malabana Primary School, as I showed earlier, it's on the island of Lake Victoria, where the highest lightning density is measured. And the installation will protect 515 people, including 472 students and 43 teachers and their families. So we built all these lightning system in those schools in the community. So when there's a thunderstorm, the whole community can go to the school to protect themselves. So let's come back to the largest public Africa lightning injury report database that we have been collecting for many years. As I mentioned, we have 41 out of 55 countries. And this, we have submitted a conference proceeding, and it was accepted by the 2024 International Conference on Lightning Protection, which will be in September in Germany. So it took a lot of effort to collect the reports and archiving them. So the reports are collected from the news by the staff members, if it's in English, or by some citizen reporters, if it's in other languages, especially local African languages. We have a couple citizen reporters that regularly report on these lightning events. They will translate and send us some of the information. The reports are archived by the staff with a standard format with date, time, the web link, and a short description of what happened. And we share them with in English and in their native language on the social media. As of the end of 2023, we already collected almost 900 reports in Africa. You can see some of the countries have much larger numbers, and some of the countries only have a few. So some of the countries like Egypt, it's probably more realistic because they're in the northern Africa where they have fewer thunderstorms or drier. So it's more reasonable. But some of the countries, even though they have fewer numbers, it doesn't necessarily mean that they have fewer lightning fatalities. It's probably just because of, poor reporting system, or people tend not to report these because they thought it's a sin from the God, it's a punishment from the God. Or, if they're in a chaos, in a war, they don't care about who were killed by lightning. So these are just the general stats by country. This is the number of reports by each country. As I mentioned earlier, in the northern Africa, they tend to have fewer thunderstorms, so they tend to have fewer reports. But it doesn't necessarily mean that the lower numbers indicating fewer lightning fatalities. This is the number of reports per million population. It's kind of similar, but there are some differences between these two. But again, lower rate doesn't necessarily mean that they have fewer lightning fatalities. We have 2 students working with me archiving these reports and get the stats. This is just showing a case study that I've done. So this is for the country of Angola, and this is how many cases were reported each month. In some African countries, they have 2 seasons, a wet season and a dry season. So in dry season, there's nothing, nothing here, but in the wet season, they have more reports. So these are just the casualties by gender and the casualties by location and activity. And you can see 45% of the cases occurred inside the home, which means that their home was not lightning safe. So some of the major differences between Africa and US. So if you remember, the deaths per million population in the US is pretty low. It's less than 0.2, as opposed to a much larger number in Africa. So it goes from 2 to even up to 84. And also, I want to point out that even for these reports that we have been collected, we're pretty sure it's not a complete set. So these numbers could be even higher. So for the deaths, injuries per case, in the US, it's mostly just 1. But in Africa, usually it's multiple people. It's because usually the lightning strike a place where they have a lot of people, either at home or inside a building, or they are working outside. So in the US, most of the lightning fatalities were related to entertaining activities, but in Africa, it's mostly working related. For example, doing agricultural work, or they're at home. To promote the lightning safety around the world, we made this International Lightning Safety Day. So the tragedy in Uganda back in 2011 was not only the reason for ECLINET to establish, but also the reason for us to make this Lightning Safety Day. So the world remembers these children every June 28th as the International Lightning Safety Day, and annual events will take place in local regions or internationally. So we have this annual virtual event. This is a group of 2021 event. So we discuss lightning safety strategies, their local educational programs, technology or methodologies. We also discuss the progress that we have made and the challenges we've been facing. We have participants from 20 plus countries across Americas, Africa, Europe, and Asia. But the most challenging thing for this annual event is actually how to find a time, like 3-4 hours, that would work for everybody, especially we have people from South Asia and Southeast Asia and Western US. It's just hard to find a time that works for everybody. But we do have the 2024 International Lightning Safety Day event coming up on June 28th, which is 3 weeks from now. We have 2 keynote speakers, Hiki from the WMO and Nicola, who is a lightning survivor. And this year, it would be our first time to live stream the event on YouTube. And it's going to be the first time we'll have a live chat with local people in Brazil, France, and Uganda. So they have, they host their local events, and they have people coming in to talk about lightning and lightning safety. And we're going to have a chance to see them live and say hi. So if you're interested, here's some of the Zoom information. So to move forward, we're seeing a very promising decreasing trend in the US. It took us 30 years from here to here. It was not easy, but we did it. And we are seeing similar trends in other countries. We want to see it as a global phenomenon. It would not be easy, but if we work together, we believe that we can do it eventually. And we have the high technology to help us to achieve the goals. So we have the geostationary lightning mappers, or the GLMs, that's on board the GOES East and the GOES West satellites. They're continuously monitoring lightning activity across the Americas and adjacent oceans. I'm not sure if you can see it clearly, but these yellowish, greenish dots here is actually the GLM data, or the lightning. So GLM data has been widely used in the US and in the South America, and they have successfully proved that they have been very useful in a variety of applications that I'm going to talk about in a little bit. The European Space Agency also launched their own lightning imager, or the LI, which will cover the Europe and Africa. And the LI has similar sensor specification as GLM. So what we have done successfully for GLM could be transferred to the LI. So here are some of the examples for the GLM applications. So GLM has been very helpful for improving the nowcasting and forecasting, especially for severe weather. There's a lightning jump phenomenon that we have been observing 10-15 minutes before a severe weather, such as a tornado or strong winds. So having the GL1 lightning observation will help the National Weather Service to better nowcasting the severe weather. GLM also help characterize the lightning risks and hazards for enhancing the aviation safety. GLM data has been successfully helping enhancing the early detection of lightning strikes that most likely to ignite wildfires. So these are some of the successful applications that we have been developing, and these algorithms and technologies can be transferred for LI to help do the same thing for Europe and Africa. But lightning is not a regional or local thing. It's a global phenomenon. A couple years ago, lightning was selected as one of the essential climate variables. Since then, a lot of studies have been done, but still, how lightning affects climate change and vice versa is still understudied. So more research is needed. We have been recently detecting lightning in the Arctic area. This is it because of the climate change, or is it just because of better detection technology and sensitivity by our networks are still unknown. So we need to keep an eye on that and keep monitoring the global lightning activity. So what will happen next under climate change? Some of the studies have been showing projected increase in lightning strikes in the United States due to global warming, projected decrease in lightning under climate change, hiatus in global warming, drier climate, more lightning. This paper actually came out last night. Increase in lightning around South China Sea under climate change. So there are different results from these research. We're not fully understand what's happening, fully understand the relationship between global lightning activity and the climate change. So hopefully with the technology, with the new generation satellite, we'll be able to have a better understanding of these and have a better understanding of how lightning activity can affect the climate change and vice versa. And with that, I'll end with my talk, and thank you very much for your attention.
Thank you so much, Daile. This was a really a great talk and really important topic. I don't know if you guys are listening online, please submit your questions if you have any or comments on Slido. We do have 3 comments from Ariane Cooper, just probably to finalize some of your points. Marianne mentions that there are more than 2,000 subscribers to the newsletter since 2019, currently more than 3,000, and that there's been over 12,000 students and teachers protected since 2016. This is impressive, and we thank you for sharing that data and those impressive results and your task in Africa related to lightning safety. I don't see any more questions, but I do have questions. So I've seen that a lot of on the slides, a lot of the lightning data was reported from Baisala, and I was wondering, do African countries, well, especially probably Uganda, that you know better, have the possibility to access lightning monitoring or lightning detection systems, or is it something that it's still an ongoing process?
Yeah, that's a really good question. So definitely Visa data is a commercial data set. So they're not like publicly available for the most part. But they do provide free data for researchers, especially if you are in academia. They would, if you request the data and then tell them what you're working on, they usually provide free data. But for like the commercial use, like in aviation or in the airport, that's, you have to pay, I think. And I'm not sure if the National Weather Service there have any relationship with Vaisala. So, um, yeah, so it's a little bit complicated. It's not as easy. But hopefully the LI on the European satellite would be available soon. I know they are having really good cases already, and they have been showing very good lightning in the thunderstorm. So I think maybe in the near future we'll have these data available for Africa so that they can have it, because GLM has been proved to be very, very useful, especially for filling the gaps for radars. So let's say if there are areas where they don't have the radar coverage, GLM can be a proxy for radar data. And also if the radar is turned down for some reason, GLM is helpful. So hopefully that will also be something that will be available for African countries.
Thank you so much. I think that Kelly has a question. Go ahead, Kelly.
Thank you, Anna. Yeah, great talk, Daile. I was just following up on that last comment. I'm wondering if you could tell us a little bit more about this relationship between using lightning data as it relates to the intensity of the convective system. I think this is a very relatively new topic, or especially in the tropics, right? So I'm wondering, have you looked at that?
So yeah, so there's actually have been a couple papers out about the lightning jump, which is so if you look at the total lightning, which is both cloud to ground and intra-cloud lightning, and you'll see a rapid jump that usually happens, let's say 10-15 minutes before a tornado or a strong winds or like hail events. So that's something that, the community, lightning community has been working on to see if we can use that as an indicator of, for now casting a like severe weather. So they have been using it in the National Weather Service for a while, and it's been useful, but still there are issues because we're using the GLM. And when there's a convective system developing, you usually have a lot of lightning flashes, but also these lightning flashes are very small and dim. So it's kind of hard to see it from the space. So we do see in some cases where we see a rapid jump in lightning, and then there's the severe weather. But sometimes we don't see the trend just because maybe, the flashes are still there, but like the GLM didn't see it. So that's something we still have to work on to make better algorithms or to better understand what's going on. But that's something they have been using in the National Weather Service. And one of my colleagues in Maryland actually went to the test weather bed 2 weeks ago and talking with the forecasters there. And they're indicating that GLM is very helpful for their nowcasting, but there are still issues that needs to be improved.
Very interesting. Thank you.
Thank you.
Okay, we do have some questions now online. Simon Castro Woolridge says, I used to work in landline and UX or risk education. One of the challenges of risk education is to convince donors of the value of a work compared to other activities that they could fund. What impact metrics do you use to make your case? And
yeah,
and he also says it was a typo, landmine, not landline.
Yeah, that's a really good question. So it's hard. It's even harder to convince the donors. There's values. So usually the donors are someone we know of, friends or friends' friends. There are also donors from lightning survivors. They already suffer, so they know the risks. We do talk with some of the people we know for family founding grants opportunities. So it's hard because sometimes if we are just saying like we're going to protect one of the schools and that's going to only protect 100 people, then it's not like consider a big impact. But if you consider, let's say, that if one single strike could potentially killed 50 people and injured more compared to people may have suffering, so 2,000 people may have suffering the air pollution, then I think that's more urgent. But still it's hard, so it takes a lot of effort, and we have been losing some donors for some reasons, but we're still having new donors. It's challenging for sure.
Thank you. We also have a comment from Ronald Holle. I hope I'm pronouncing right the name. It says a number of users such as mines and airports in Africa have real-time data subscriptions for a fee. They can be started up quite quickly in real time. I work at Vaisala for 20 years. So that is great. I don't know if you want to add any comment, Daile.
Yeah, thanks, Ron. I didn't know much about the Vaisala business, but yeah, I would guess if you pay for the fee, you can use the data for the airplanes, airports, I mean.
Awesome. I don't see any other questions from the audience, and so I think that we could leave it here. So thank you very much for all of you for joining us today. This was really an impressive talk. Thank you so much, Daile, for the work and for your team, for the work that you do, and for sharing these results and this information to all of us, and for all with all of us, sorry. And yeah, just probably join us for the lightning safety day. And yeah, and we'll see you all soon. This meeting has been recorded, and as soon as we have the record, we will post it online on YouTube for those who want to share it or who have not been able to join us today. And we'll also share it in the mailing list for the seminar, UCAR Africa Seminar. So thank you very much all, and thank you so much, Daile, for your talk today.
Thank you.
Thank you.